ICHSA 2022. I'm Jung-Hoon Kim, and I'll be chairing this keynote lecture session, which will run from 14:20 until 15 for 40 minutes. And the keynote speaker will have 30 minutes for presentation and followed by 10 minutes for Q&A. The speaker in this session is Professor Jagdish Bansal, an associate professor at South Asian University in New Delhi, India. Professor Bansal has obtained his PhD in mathematics from IIT Roorkee. His research interests include swarm intelligence and nature-inspired optimization techniques. Recently, he proposed an optimization algorithm called spider monkey optimization, which is being applied to various problems from engineering domain. He has published more than 70 research papers, and he is the editor-in-chief of International Journal of Swarm Intelligence, and he is the General Secretary of Soft Computing Research Society. So today he will be talking about very interesting topic, drone swarm, concept, challenges, and applications. And please welcome Professor Bansal. And if you have any questions, please feel free to ask questions in the chat window. So even in the middle of presentation, you can type your question so that I can, at the end, I can read your question. Thank you. Professor Bansal.
Thank you, Professor Kim. It is my privilege and honor to speak here in this one well-reputed conference. I'm actually honored to attend almost all the previous 6 conferences. I attended the first conference in Korea also and received, in fact, the Best Paper Award also. Thank you so much for establishing such a nice platform for the researchers to share their idea. Good morning and good afternoon, everybody. Today I'm going to speak on the drone swarm, which is relatively latest technology, and the future lies, future of war technology, future of the delivery lies with the drone swarm. So I'm going to share that what the swarm intelligence based algorithms or the nature inspired based algorithms can do with the drone swarms. Let me just share my screen and then we'll start. So is it okay? My screen is visible? Professor
Yes,
Kim,
it looks okay.
Yeah,
it looks okay.
In this talk, I'm going to cover why the drone swarm is actually required. What is the concept of the drone swarm? What are the challenges in making the drone swarm? Various application areas in short I'll discuss. What kind of drone swarms are available these days and what kind of drone swarm are actually expected? What is the present status and the future of the drone swarm? And at last, which is my research in this area, drone flocking optimization. So that I'm going to share. So initially actually just first 10 minutes are about the drone swarm, and at last 20 minutes I'll discuss the research on that, my research on that. So it is always a powerful tool to use the multiple agents to solve a single problem. So it is always beneficial to have the swarm to solve the problem. When instead of individual efforts, the collective efforts can solve the problems in better way. I hope everybody of us know we are working in this area. So emulating or simulating these kind of phenomena to the drone swarm can also benefit us and can have myriads of applications: faster and more efficient surveillance mapping, factory automation, collective cargo, efficient disaster search and rescue. This is the one most important. And in India, the government of India is also working very intensively to solve for the application of the drone swarm into this problem, disaster search and rescue. Heterogeneous swarms for agriculture monitoring, not only agriculture monitoring, but for the agriculture, other benefits also. For example, if you want to spray the pesticides into the agriculture farmland, then the drone swarm can help us to do that job very efficiently. Performance artworks and display. This is another area. On 26 January is our and the beating retreat ceremony in India. In Delhi, 1,000 drones were flown together. They made different kind of shapes. You can see the videos on the YouTube. So 1,000 drones flown together autonomously with no central control, with no control from the base station. They made different kind of shapes. So these kind of applications may also be there. Pursued evaded situations in defense scenarios. So I worked with the Indian Air Force in case of the drone swarm algorithm development. And I realized the scenario that after 20 years, there may not be any fighter planes, only the fighter drones may be there, and there may not be any job for the fighter pilots. Only the drone pilots' job may be there. So this is the future. Swarm intelligence, not much to say to this audience about the swarm intelligence is, of course, one of the most important agenda in the soft computing. It has gained a lot of attention in the industry also. There was a report, industry report, which says that in 2017, the global swarm intelligence market generated USD 10.5 million. Of course, this is not a big deal, but the most important thing that the report says is this compound annual growth rate, CAGR, which is over 28% in next 5 years. So this suggests that the swarm intelligence is important and has the various applications into industry. Why the drone swarm is becoming popular? The one immediate application of the drone swarm is in the military one, but their civilian applications are also, of course, very much popular. The China, Taiwan, Korea are, of course, ahead on this. Amazon already has started the delivery drones. Just imagine if so many, everybody in my society, suppose everybody is ordering through Amazon, and Amazon is delivering through drones, then definitely there must be some communication among the drone, and they have to avoid the collision. They have to make sure that the delivery is in proper way. In that case, of course, we require some swarming among those drones. Okay, so this was the one research paper that I found in 2018. This paper, Optimized Flocking of Autonomous Drones in Confined Environments, was published, and I found this is the one basic research and one authentic research that has been done. I want to share a few clips that authors have uploaded as a supplementary material from this research paper. I want to share some clips from those. So
avoid collisions with each other.
These are the 30 drones. Those are flying together with no central control, and this is a real flight. It's not a simulation, it's a real flight.
Virtual obstacles. This is a challenging.
I'm just skipping and coming to the actual. So here, this is the real flight simulation where they can avoid the obstacles and can avoid the walls. Of course, these are the GPS walls in the real scenario.
Inform the other walls. This is a very.
The most important thing is about this, the crowd management of, like, for this drone, suppose this particular drone is moving towards this corner, then these drone can understand and they change their direction without reaching there. This all because they are communicating with each other and taking the advantage of the discovery of these drones. So they are behaving like a swarm. You can see there.
Similar situations in large football
stadiums. It is of course like a crowd somewhere. Let me show you some. Yeah, here in this, at this moment here, in the night flying, the directions are shared among the drones, with the help of this color coding. A particular color is showing a particular angle that they have to move in this particular direction. So there may be many other strategies also for the sharing of the information among the drones. It may be based on some data, or it may be based on some color coding. They have implemented for the night flying, they have implemented with the help of this color coding. And you see this beautiful video of flight, real flight. This is the real flight, and it is a complete autonomous system. All the drones are flying, take off, they make immediate consensus and decided to move in certain directions. So before we move to the optimization of the drone swarm, let us define formally what is the drone swarm. So any group of drones cannot be the swarm. This is to be noted that any group we cannot say that it is a drone swarm. For the drone swarm, it is an interacting, all the drones should be interacting with each other. It is an autonomous group of drones, and it should be able to perform some task. So an interacting autonomous group of drones assigned to perform one or more than one task simultaneously. Then we will say that it is a drone swarm. It must be an autonomous system. There must not be any central control. Of course, you know that this is the basic requirement to have the swarm intelligence. All drones should be interacting with each other. There must not be any individual interaction that, okay, only two drones are interacting and these two drones are interacting. There must be multiple interaction among the drones. So actually, basically the expectation that for the drone swarm, it is expected that every drone has same configuration. However, sometimes it may not be possible. So some ADRs are there. So to have the connection, to share the connection with the base station, to get the feedback from the drone swarm to the base station. So some ADRs may be there, or some ADR may also be there to guide the path for the remaining drone swarms. So the mother and slave, mother and child drone kind of concept, master slave kind of concept is there, which is now the reality. However, the technology is being developed where all the drones will have the same configuration, which is actually the basic definition of the swarm intelligence, will have the same configuration, and any drone can take the place of anybody else, so that the most important part, self-healing, can be achieved. Self-healing means if one or more drone crashed during the mission, other drones can take their place and can perform the mission. So this is being developed. Right now, of course, all kind of sensors, all kind of networks and computing devices cannot be put on all the devices. It is very costly also, and the performance deteriorates. As soon as you increase the weight of the machine, the endurance will decrease. And so sometimes we assign certain tasks to certain drones, and certain drones, other tasks are assigned. Okay. So the ultimate objective of the drone swarm is to develop an autonomous system consisting of a group of drones, typically 30 or more. Actually, it is found that if you want to solve most of the real world problems, for example, the defense related or some search and rescue mission related problems, or some disaster management related problems. Suppose there is a flood in certain area and you want to search the survivors in minimum possible time, then usually 30 or more drones can work effectively. So the ultimate objective of a drone swarm is to develop an autonomous system consisting of 30 or more drones, and the connections among them, how they are connected with each other. If everybody is connected to everybody else, then there may be a lot of communication, and the communication delay may be there, and they may collide with each other, or this connection may delay the mission. And therefore, you know that the less connected structures are better. In swarm intelligence based algorithms also, we prefer the local best swarm intelligence based algorithms, L-based algorithms. the less connected structure, ring topology kind of communication networks, we prefer over the fully connected structure. So similarly here in the drone swarm also, we would prefer less connected structure, but ultimately the information one has can be shared to anybody else through via other drones. And of course, the ability to perform a well-defined task. If there is a drone swarm for the defense, it can